iPro Camera Application Platform provides an SDK that enables the development of applications that run inside iPro cameras, allowing partners to provide customized solutions to end users in a variety of industries. SDK version 3.10 makes it even easier to develop Python applications using Jupyter Notebook. The conventional Python application development process requires writing code on a PC, building the application, installing it on the camera, checking logs, and debugging. Developer needs to do this process repeatedly. With SDK version 3.10, you can use Jupyter Notebook to code on the camera and see its behavior in real time. After installing the base Docker application on the camera, you can use the Jupyter Notebook UI to code and debug on the camera. The items required for development are listed here. To develop, you need a camera with an Ambarella CV5-2 SoC that supports Docker. Once development is complete, you will also be able to create an application that will work with cameras with other SoCs. To download the SDK and check detailed instructions, please register for an account on the developer portal site listed in the description. Let's start with development procedure. First, install the Docker extension module and the Notebook for Python, which is the base development application in the SDK. You can install in the same way as another camera application. After installation is complete, open the application and the Jupyter Notebook UI will be displayed. From then on, you can develop using the same operations as using Jupyter Notebook on a PC. Here, I will explain the tutorial included in the SDK. This tutorial describes how to use the API for camera application from a notebook. First, I'll perform import and initialization to use the API. As you can see, code can be executed in real time on a notebook. Let's try running code that get and print basic camera information. You can immediately check the results. You can also specify and execute a Python script that you prepare in advance. Running a script to get basic information about the camera shows the result in the same way. SDK also provides templates for developing partners' own application. Let's develop an application that acquires image data from the camera and displays JPEG images. Open the notebook in the tutorial folder. First, I'll make the imports necessary to use the API and also import additional libraries needed to perform image processing using OpenCV. Next, define global variables. Here, I'll define the path to save JPEG images in memory. Next cell is a function required by the SDK, so just run it as is. Next, define the event loop processing. Within this function, add a callback function to the event loop for receiving image data from the camera. Here, register a callback function for acquiring full HD resolution images at 1 FPS. Next, I'll implement the callback function I just registered. Processing to convert the YC format image data received from the camera to RGB format and save it as a JPEG image. Next is the function when the application receives an HTTP request. Here, I'll implement the response by reading the JPEG image saved in memory. Execute the next function for when the application closes. Finally, there is the main function which starts the functions I've implemented so far. When the application is started, saving JPEG images at 1 FPS starts, and URL for HTTP access to the application will be displayed. You can click it to view the JPEG images. The source code is now complete. Next steps is how to release camera application. You can output the code in the notebook as a Python script. Copy this Python script file in the SDK folder and make application. The application file can be installed from the Camera web. This video explained a new way to develop Python applications, so be sure to try out the new SDK.